Hi, my dear students. Welcome to India's biggest online platform, Yummy Educational Institutions. We are discussing ray optics. In this session, we are going to discuss reflection in a plane mirror. So, we'll be covering image formation in the mirror in this particular session. Let's start the session. See here, plane mirror. Here, this is the plane mirror. Now we are going to discuss the phenomena of reflection in plane mirror and image formation in the plane mirror. Just observe here, silvering of thin glass plate on one side. Then only you can call it as a mirror. One side of the glass, you will be coated with the silver. Silver coating is made on one side of the mirror. Then only you are able to see the images in the mirror. So here, this is the reflecting side. Here, silvering side. Here, the coating is made on right side of this particular glass plate. Now, we need to see the phenomenon of reflection. See here, incident beam of parallel light rays. A bundle of rays is called as beam. Here you can see incident beam of parallel light rays. So these all are incident rays incidenting on glass plate which is coated with silver at one side. You can call it as a mirror. You can call it as a mirror. This is the mirror. Understood now? So here one side of this glass plate is silver coated. One side is silver coated. Understood now? Now incident beam of parallel light rays. Here these all are incident rays. After that, these will be reflected back to the same medium. All are reflected rays, parallel reflected rays. You can call it as a reflected beam of parallel light rays. Bundle of rays, you can call it as beam. This is the beam of reflected rays, complete reflected beam. Understood now? So this is the reflection phenomenon mirror. Now we need to calculate incident angle and angle of incidence and angle of reflection and image distances, those things. Complete image formation in the mirror we need to discuss in this particular session. See here, now just observe plane mirror. Here this is the normal is drawn perpendicular. This is the normal perpendicular to the mirror, and an object is placed at a distance L from the mirror. Object is at left side of the mirror. Now an incident ray is incidenting on mirror, then it is reflected back. One more incident ray incidenting on the mirror, it is reflected back to the same medium. This is the reflected, and this blue color is nothing but reflected ray. This is incident ray. This is incident ray. Incident ray. Incident ray. Incident ray. This would be reflected ray. I can say that reflected ray. Okay, so incident ray, this is also incident ray, incidenting on the mirror and reflected back. So now, the point of intersection of the extension of these reflected rays is nothing but image. This is the image. Here we are extending the reflected rays. We are extending the reflected rays. The point of intersection of extension of the reflected rays is nothing but image. So the image formation on right side of the mirror. Here this part actually image formation in the mirror, within the mirror. You will see that image in the mirror itself. Here this part is silver coated. Okay na? So right side of the mirror, here it is silver coated. It is very important point. Extension of the reflected rays, the point of intersection of extension of reflected rays is marked as image. This is the image formation in the mirror. Now we need to calculate distance, perpendicular distance from the mirror to the object, perpendicular distance from the mirror to image. Both are exactly same. That we need to prove in upcoming slides. Understood now? Here it is the object. A ray is coming from the object and incidenting on the mirror. This is the incident ray. Then this would be reflected, and one more incident ray is incidenting on the mirror. Then it will be reflected. The point of intersection of incident rays is marked as object. This is the object point of intersection of incident rays. See here, distance L, both will be same. L is the perpendicular distance measured from the mirror up to the object. This L is nothing but perpendicular distance from the mirror. This is, you will be drawing a normal to it. This distance and this distance both will be exactly same. Okay na? So this is the axis of the, this would be axis of the mirror. Perpendicular distance from the axis of the mirror we need to calculate. See here, image. For image formation, for getting an image, we need to do like this. We need to calculate the point of intersection of the reflected rays is marked as image. Understood now? So we extended the reflected rays. Okay. So the point of intersection of reflected rays, nothing but image. The point of intersection of incident rays is marked as object. These two are very, very important. Once you get this particular point of intersections, then you will be drawing axis of the mirror. Okay, now you will be drawing one line like this. Then you can measure perpendicular distance from the axis of the mirror to image and object. Both will be exactly same. You will be proving it here. See this? This is the thing. Plane mirror is nothing but is a perpendicular bisector of line joining the point object and point image. It is very, very important point. Plane mirror. This is the plane mirror is the perpendicular bisector. Perpendicular bisector of point object and point image. Perpendicular bisector means this is the line, OI is the line, OI is the line, image is the this particular mirror bisecting the OI. Bisecting the OI. Bisecting means what? Perpendicular bisector. This is perpendicular 90 degrees and L and L. These two distances are exactly same. These two distances are same. Mirror is the perpendicular bisector. It is very important point. See here. You can take this. Plane mirror is a perpendicular bisector of the line joining the point object and point image. Okay, now we will be proving it. See here. So what is the formation of image on I? After that we can prove that particular perpendicular bisector business. See here, it is the I. Same way, object, this is the object, rays are coming, incident ray, reflected ray, incident ray, reflected ray. The point of, this is A, incident point A, one incident point A, another, this is B, and another incident point C. Here you will be drawing perpendicular or normal. This is the normal. I can say this would be normal. We need to draw normal at point of incidence. That part we already discussed in the last class. So here we will be drawing one more normal. This is the normal at point of incidence. Now the point of intersection of the reflected rays is marked as image. The point of intersection of incident rays is marked as object, point object and point image. So here this is the distance. We already L and L, we need to prove it. We will be proving that. Here we already know angle of incidence equal to angle of reflection. This is the angle of incidence at this particular first point of incidence. This is the A. Here I can say that I1 and R1, I can say I1 and R1. So angle of reflection, and one more, this is the angle made by the reflected ray with the normal angle of reflection. At this point, if you apply law of reflection, here you can write I1 equal to R1 equal to theta 1. So at this particular point of incidence, you will be applying law of reflection. Here you will be getting I1 and R1 both are theta 1, both are equal. So this is the normal. At this point, another point of incidence, here this would be I2, this would be R2, I can say, R2 I can say, angle of incidence equal to angle of reflection. Here I can write I2 equal to law of reflection, I2 equal to R2 equal to theta 2. So this is the law of reflection at point C, law of reflection at point A. Understood now? So you will be getting this part. Here you got this I1 equal to R1 equal to theta 1, I2 equal to R2 equal to theta 2. Now, so once you apply the geometry, here this, if it is theta 1, it would be theta 1. Then if it is theta 2, it would be theta 2. Next, here it is theta 1, it would be theta 1. Then it would be theta 1. This is also theta 1. Understood now? This is also theta 1. If it is theta 2, and here to here, if it is theta 2, this is also theta 2. Understood now? If it is theta 2, it would be theta 2. It would be theta 2, then it would be theta 2. Very simple. Theta 1, theta 1, theta 1, theta 1, then theta 2, like this. Understood now? So here rays are coming from the object and incidenting on the mirror. With reference to the mirror, this particular thing is incident ray. This would be reflected ray at this particular point of incidence. For example, one source is here, ray is coming, incidenting on the object, reflected back and incidenting on the eye. So in this case, with the reference to this point of incidence, this would be incident ray, this would be reflected ray. Okay na? So depending on the point of incidence, you can decide which one is incident ray, which one is reflected ray. In general, I in the sense here, rays are incidenting on the eye. Complete, all rays are incidenting on the eye. That is why you are able to see the object. This is the basic knowledge related to formation of image on the eye. Understood now? Here it is what? With reference to this is the angle of incidence, I can say that this would be incident ray. This would be incident ray. Understood now? So with reference to this, here point of incidence only reference. This would be reflected ray. This would be reflected ray at this point of incidence. At this point of incidence, this would be incident ray. From here to here, incident ray. This would be reflected ray. Reflected ray. And these rays are reaching and incidenting on the eye. That is why you are able to see the objects. Okay, now. So once you are viewing from here, you are standing here and viewing. Okay, now one object is here and you can see the object and image from the eye. Okay, so these two will be forming on the eye. Understand? Rays are incidenting on the eye so that you can see the image and object. This is some funda related to image formation on the eye. We can discuss in detail in upcoming lectures about this image formation. Okay. Next, we'll be proving it. Here we already know that plane mirror is a perpendicular bisector of line joining point object and point image. That we need to prove it. It's very simple. It's an object. Incident ray is coming and incidenting on the mirror and it is reflected. And one more incident ray incidenting on the mirror and it is reflected. The point of here, point of incidence, B and C is also point of incidence, and one normal one and normal 1 and normal 2. So these all are normals drawn for the mirror. Okay, now this is the normal to the plane mirror. Now I can say the point of intersection of reflected rays is nothing but image. This is the image. Now here L and L. Initially we can take this would be length object. This is the image Li. L not equal to Lo equal to Li. That we need to prove it. So here we already done that part. Apply law of reflection at point of incidence A. This would be theta 1 and theta 2. Here theta 2 and theta 2. Next, if it is theta 1, it would be theta 1. If it is theta 2, this would be theta 2. This would be theta 2. If it is theta 1, this would be theta 1. Then it would be theta 1. Next, if it is theta 2, this would be theta 2. Then this would be theta 2. Take care of these angles, all the angles. See here, theta 2, this would be theta 1, theta 1, theta 2. Yeah. So in this manner, we calculated all the angles. Now we need to apply geometry. Now we need to apply geometry. See here, we need to prove it. We need to prove here perpendicular distance. I can say that this would be L naught. This would be Li. Li. Okay. So here theta 1, everything I am interested in upper portion. So from triangles here ABO, theta 1 and theta 1, one angle and AB, this would be AB. From this triangle ABO, ABI, both are similar triangles. ABO and ABI, both are similar triangles. If you apply tan theta 1, what you will get? If you apply tan theta 1, AB by L naught, AB by Li. So see here, from triangles is very simple. Just observe from triangles ABO, from triangle ABO and from triangle ABO and ABI, from triangle ABI. Here I can say that what is tan theta 1 here? What is tan theta 1? Tan theta 1, from triangle ABO, AB by LO. So one more tan theta 1 here, tan theta 1 here, AB by length. This is the perpendicular distance from the image to point, from the mirror to point image, Li. So from here tan theta 1 equal to tan theta 2, tan theta 1 equal to tan theta 1. Okay, na? Not theta 2. So tan theta 1 equal to tan theta 1 from these two equations. Finally, you are getting a beautiful equation. AB by, this would be AB by L naught equal to AB by Li. So AB gets cancelled out. Then L naught equivalents to Li equivalents to L. So both are equal. Now we can say confidently, plane mirror is the perpendicular bisector of line joining the point object and point image. Okay, so this is the perpendicular bisector. Plane mirror is a perpendicular bisector of line joining the point image and point object. So here this would be how much? Finally we can say this is L, this is also L, this is also L. Both are L here. So these two distances are exactly same. Understood now? So it is very simple to calculate distance of the point image from the mirror. First we need to draw axis of the plane mirror. After that we need to draw perpendicular or normal to the axis. Okay, now one axis we need to draw. So then this is the line joining the point image. You will be practicing some problems, you will become expert in that. This is the line joining the point image, point object and image. Line joining the point object and point image. Line joining the point object and point image. Here this is the plane mirror. I can say that plane mirror. This would be plane mirror. Plane mirror is the perpendicular bisector. Plane mirror is the perpendicular bisector of line joining the point object and point image. This is the perpendicular bisector. Perpendicular bisector of line joining. Perpendicular bisector of line joining the point object and point image. It is very, very important. You can write up to here. Okay, so theta 1 and theta 2 we already proved it. So one more thing, ABO and ABI both are similar triangles. So or else we can apply tan theta 1 and tan theta 2 from this triangle. We can prove it from here also. Here also tan theta 2 equal to this, tan theta 2 equal to this. From that also we can prove this particular statement. Now we need to apply this statement to solve the problems and to analyze some cases. Types of reflection. Before that, we need to discuss some two different types of reflection. Normal plane surface, and then if it is normal reflection, if it is a plane surface, a beam is incidenting. This is the beam. Okay, so parallel incident rays, and it is reflected. So here this is a regular reflection. In this regular reflection, this part all reflected rays or in the same direction. It is very simple. Angle of incidence equal to angle of reflection. All angle of reflection will be same. That is why all reflected rays are in parallel. So reflected light rays are in same direction. In regular reflection, sharp image is formed. It is very important. Sharp image is formed in the regular reflection. And rough surface, this is the generally polished surface. Okay, nothing is mentioned. We need to assume it as polished surface. I can say that this is the polished surface. Plane surface in the sense, here it is polished surface. Here rough surface. If it is a rough surface, so yeah, we are talking about surface. Rough surface, all incident rays are parallel, but reflected light rays, all reflected light rays are not in same direction. See here, this light ray is going in this direction. This light ray is reflected in this direction. This light ray is reflected in this particular direction. It is pure surface phenomena. If it is a rough surface, the reflected rays will be like this. So you can write, this is the diffused reflection. Diffused reflection. Regular reflection, straight away you can apply law of reflection. If it is the rough surface, diffused reflection will take place. Here, not clear. I think a clear image won't be formed. Understood? Na? In diffused reflection, clear image is not formed. Understood? Na? This is all about some classification of reflection. I repeat, we are having two types of reflections. One will be regular reflection and diffused reflection. In this regular reflection, all reflected rays will move or travel in the same direction. All reflected rays are in the same direction. But in case of diffused reflection, reflected rays are not in same direction and not clear image. Clear image won't be formed in case of diffused reflection. In case of regular reflection, clear and sharp image will be formed. In case of regular reflection will occur when the surface is polished or plane surface. Diffused reflection will occur when the surface is rough. That is for rough surface. This is all about regular reflection and diffused reflection.